The Department of Energy's Building America program utilizes numerous research teams to research and develop energy-saving building technologies. A recent survey asked homeowners how they would best spend an extra $5,000 on a new home. At the top of the list were improvements to energy efficiency. Skyrocketing energy costs and increasing consumer demand for energy performance are driving the development of new energy-efficient products and building methods, making it an entirely different market for builders. Home buyers not only want more energy-efficient homes, they expect it. Homes account for 21% of the energy used in the United States every year, with an average annual utility bill of over $1,700. Home buyers are increasingly concerned about rising energy costs and the impact of fossil fuels as a major source of greenhouse gases. Spearheaded by the U.S. Department of Energy, the Building America's Builders Challenge is a voluntary effort to provide participating home builders with an easy way to differentiate their best energy-performing homes from other products in the marketplace and to make the benefits clear to buyers. Nearing the end of 2010, 644 registered builders built over 4,400 homes that met the Builders Challenge goals, resulting in energy savings of $3.4 million and over 16 million tons of reduced CO2 emissions. The 2011 NextGen Flex Home, the national demonstration home at the International Builders Show in Orlando, Florida, is designed to meet the Builders Challenge. We incorporated ideas from the Builders Challenge in making this home score low on the Energy Smart Home Scale. A special note that after the show is over, our goal is to donate this special NextGen home to an organization that provides assistance to our wounded vets as they recover from wounds sustained in service to our country. We use the Energy Smart Home Scale to demonstrate the home's energy savings. This scale allows home buyers to understand at a glance how the energy performance of a particular home compares with others. For instance, a typical existing home has a score of 130. A new home has a score of 100. The goal on this project is to meet the Builders Challenge score of 70 or less. DOE's ultimate vision is that the Builders Challenge will help new homes achieve an improved energy efficiency rating, meaning that a consumer will have the opportunity to buy a cost-effective, energy-efficient home anywhere in the United States. For the consumer, the Builders Challenge answers the questions, will this home help me save money on energy bills, and how does it compare to other homes in my community? When shopping for automobiles, consumers can compare their miles per gallon with other cars and see how their car's energy performance compares to other cars. The Energy Smart Home Scale will allow consumers to get similar information when shopping for a home. In building an energy-efficient home, much of the work begins in the design process, carefully planning, designing, and trading off systems in the house to achieve the lowest Energy Smart Home score possible. For example, an efficient building envelope can contribute to money savings when used in conjunction with the proper heating and cooling equipment. We started with the building envelope. 31% of all air leakage can be attributed to walls, floors, and ceilings. The walls of this home were filled with spray foam insulation that is blown in the wall cavities before wallboard is installed. The expansion of the foam insulation seals up all cracks and gaps in the wall and totally fills the airspace, keeping outside air out and keeping conditioned air in. The spray foam insulated walls provide a high insulation value. In addition, guarding against air and moisture intrusion ensures a healthy house with no mold and mildew problems. Locating the HVAC air ducts in a conditioned attic space can reduce heating and cooling costs by 10 to 25%. Insulating and sealing the attic roofline with more of the spray foam insulation and air barrier system is a straightforward way of placing the HVAC system in a conditioned space. Spray foam insulation provided an R value of 30, a much needed number in the hot Florida climate. Another important part of the building envelope attaining peak energy efficiency is the windows. The windows installed on this project have a solar control low E glass coating. The E in low E glass stands for emissivity. Low E glass works by reflecting heat back to its source. It does this by utilizing an ultra-thin metallic coating on the glass. The total solar energy transmitted through the glass is almost 50% less than that transmitted by standard clear insulated glass. In addition, argon gas and a foam spacer between the panes of glass dramatically improve thermal performance. Among other things, sunlight contains visible light, UV light, and infrared or IR radiant heat energy. Visible light enables us to see things. Ultraviolet light damages your skin, wood, fabrics, and causes color to fade. Low E glass with solar control has the ability to allow most visible light to pass while blocking much of the UV light and IR radiant heat energy. Also, the proper installation and flashing materials used with the windows ensured reduced moisture and air intrusion into the interior. From the windows, we move up to the roof. This metal roof is ENERGY STAR compliant. The reflective material contributes to a cooler attic space. To reduce electrical usage in this home, we worked with Lighting for Tomorrow, which is an annual competition organized by the American Lighting Association, the U.S. Department of Energy, and the Consortium for Energy Efficiency. The competition results in new ideas in energy-efficient lighting design that results in lower energy costs using a combination of compact fluorescent bulbs, LED, and lighting controls that save energy without sacrificing warmth, beauty, and the overall quality of light. In addition, the next-gen Flex Homes appliances are all ENERGY STAR rated, helping to realize even more energy savings. In the average electrically heated or cooled home, the electric or gas water heater storage tank is the second largest user of energy, ranging from 20 to 40% of total energy used. On this project, we instead are using an electric tankless water heater. It heats water only when you need it and provides a continuous and endless supply of hot water. Working alongside the tankless water heater is an electronically controlled pump and valve assembly that takes the room temperature water that sits in the water pipes and circulates it back to the heater. The result is hot water that arrives at the fixtures anywhere in a house an average of 4 to 5 times quicker, contributing to dramatic water savings. For efficiently heating and cooling the house, we are employing a heat pump system that can heat, cool, and condition the air quality of the home affordably and quietly. The efficiency of air conditioners is often rated by the Seasonal Energy Efficiency Ratio, or SEER. The higher the SEER rating of a unit, the more energy efficient it is. Our air conditioning system has a SEER rating of 15. While energy-saving methods are the prime goal of the Builder's Challenge, generating energy can also help offset energy costs and lower the Energy Smart Home Scale score. The next-gen Flex Home is gathering energy from wind this year. The wind turbine we are using is compact, produces minimal noise, and delivers an efficient 163 kilowatt hours per month at an average wind speed of 13.4 miles per hour. In addition, with solar panels added to the home generating 3.5 kilowatts of power, it lowered our Energy Smart Home Scale score to 38. After construction was completed on this project, the E-scale was established with the reputable Home Energy Rating System, or HERS index, developed by the Residential Energy Services Network. The energy rating for the home was conducted by a ResNet certified energy rater for the performance pathway. The goal is to achieve a score of less than 70. The average U.S. home scores 130, and typical new home construction scores an average of 100. The next-gen home achieved an Energy Smart Home Scale score of 38. That exceeds the Building America benchmark requirements and makes the home far more efficient than today's standard home. The Builders Challenge estimates that by constructing 220,000 homes to 70 on the Energy Smart Home Scale by 2012, participating builders will be taking the equivalent of 50,000 passenger cars off the road for an entire year and will save homeowners $143 million on their energy bills. Builders, when it comes to energy performance, the Builders Challenge is your path to a distinct competitive advantage. At last, you have a clear way to highlight features that surveys show is increasingly pivotal in home buying decisions. People increasingly want these types of low-energy homes, and it's the perfect time for builders to make these next-generation homes more available and give themselves a significant advantage over their competition while helping us to reduce our nation's energy consumption. For more information on the Builders Challenge, visit the following website. And for information on the best practices and research pertaining to building energy-efficient homes, visit this website.